Good afternoon and welcome back everyone. For our next presentation, we have Sto Moller and he's going to present on simplify, optimize and enhance AWS network management. Please welcome Sto Moller.
Rod Stollmuller, hello, how are you guys? We'll start with an easy question for me to get to know my audience. How many of you have workloads in AWS? Yeah, okay, so at least you're awake and you're raising your hands. How many of you have multi-cloud environments? Okay, good, that's gonna be good. How many of you have heard of Aviatrix? All right, a few, that's good, all right. So what I want to do is go through, give you a little bit of background about Aviatrix, talk to you a little bit about some of the things that we do, especially about our distributed cloud firewall, and give you an idea of what we're doing there. But we'll start with giving you a little bit of background. So we were founded in 2014, but in 2018, we were the transit gateway in AWS. And then AWS introduced the AWS Transit Gateway. So what we did is we built out the capability a little bit more and made it work in other clouds. So we support Azure and Google and Oracle and Alibaba so that you can have the same kind of consistent networking, consistent security, consistent automation across multiple clouds. Now in 2020, we introduced secure cloud networking because we started adding security and embedding that into the network environment itself. So leveraging that distributed system, but also to do security. And in 2023, we now have over 500 enterprise customers, over 50 of the Fortune 500 in 25 countries around the world, and ranging in size from 10 VPCs all the way up to 5,000 VPCs. So we have very large enterprise customers are our typical customer base. So if we look at what exactly we are, we're a distributed system. So when you go into the marketplace, what you're downloading is our control plane, the controller. And the controller is what will deploy our distributed system, which is distributed processing capabilities across the different environments. And this provides the networking. This becomes the network data plane. It gives you embedded telemetry, which gives you a lot of the visibility and management that I'm going to be talking about here. It also gives you the embedded security that things like distributed cloud firewall are based on. It is whoop, that just went all by itself. It does give you consistency across environments, and it's proven at scale. Like I said, we have customers with 5,000 VPCs. So the three main things that we do for customers is reduce costs, improve security, and simplify operations. So let's just start with simplifying operations. So basically, we have the ability through the telemetry that we have to give you a lot of visibility that goes beyond what you can get with the native constructs. So we can do things like build a dynamic topology map, which shows you across your clouds, both in AWS and in other clouds, as well as places like Equinix, where you might have middle mile connections to multiple clouds. And you can drill into here and get a lot of detail about latencies and what's happening. You can drill in and do packet capture and so forth. We look at all flows, so in real time we're looking at NetFlow, and you can search and sort on source, destination, port protocol, look specifically at all the traffic that's going through your network, or even look at that in a heat map point of view, right? So you can see where things are talking in your network. And security guys love this because they go, okay, I understand why I'm talking to South America, but what's going on there in northern Siberia I should be thinking about? And you can drill in and see exactly what that is. A lot of times it's just scanning, looking for open ports, but if there's a connection made, that's something you really need to start drilling into. We have something called Threat IQ, which was kind of the first time we started really leveraging this data plane that sees all of the packets. And we have the ability to look at the source and destination address and compare that to a database of malicious IPs. Now, we don't make that database. It's made by Proofpoint, same guys that do it for guard duty. But what it allows us to do is say, hey, something is talking to a malicious IP out here. And then we, because we can put in blocking rules, can shut down that communication as soon as we see that happening. So it's really powerful capability, and it really leveraged the ability to see all the traffic. We had customers that were discovering Bitcoin mining and Tor servers and DDoS bots in their cloud environments that were talking to control systems out in the world, and their normal security stack didn't see it because it wasn't going through the inspection point. But because we see all the traffic, we can see these things. We really help in troubleshooting. A lot of people like the fact that we simplify. I'm going to do a little 45-second video to show you the kind of things that you can do by just giving a source address and a destination, not address, but a source machine and destination, which could be in AWS, could be between AWS and Google, wherever it is. And then what we will do is show you the entire connectivity, how that network looks, what the latencies on all those connections are, so you can visualize that. And then we go into a lot of detail. So all of the latencies, we look at each one of the devices in the path and see exactly if there's any issues that are wrong with that. And then more importantly, we drill down and we look at things like, keep going, like route tables, whether those are goods, security groups, spoke gateway route tables and so forth in one direction, and then coming back in the other direction, and then we identify exactly where there's a fail. So you got a telephone call that said, hey, this connection is down, you can look at this. We will actually look at everything, and for instance, in this case, security group, I could then click on this and go right into the AWS security groups and fix that security group setting the way it should be. We can apply this to a specific application as well. So everything that I just showed you, we can now say, I only want to look at specific ports. So in this picture, this is actually an SAP application, and we're only looking at SAP. So we're seeing the topology of the SAP application, we're seeing the latencies on all the different pieces of an SAP, and you can drill into any of these, do full packet capture and so forth. So we have something we call topology replay. This is like having a VCR. It's going back in time. It's actually allowing you to say what changed and who changed it. So this is a really great way to troubleshoot problems as well, because you can go, it's moving by itself. Because you can go in and see exactly what has changed in a period of time and then move back and forth if there's an issue there. We can look at latencies on each one of them. So a lot of times you get a call and it says, hey, the application is running slow. If it was down, it's easy to find the problem. If it's slow, what's going on? Is it a latency issue? Was that latency a problem a week ago? Is it the same latency and it's actually not the network that's the problem? Whoops, there we go. So now let's talk about improving security. So I talked about Threat IQ being able to leverage the fact that we see all of that traffic, but we've had a partnership. We've been in security for a long time with our partners Palo Alto and Checkpoint, Fortinet, and what we do there is we help them bring their VM series type firewalls into the cloud for that centralized architecture. And we manage all of the routing to make sure that the traffic can be routed to those firewalls and inspected. We maintain session, do bidirectional hashing. There's a bunch of things that we do to make it easier for you to bring in that Palo Alto firewall. But it's still a centralized architecture, and there's issues with centralized architecture in the cloud. So that's where we introduce our distributed cloud firewall. So we started shipping this in May, and basically it's taking advantage of the fact that we're seeing all of that traffic. And because we see all that traffic, we can create, policies that allow you to define what you're looking for, just like a firewall rule. But now when we push those policies out, we push them into the distributed system. Now, the cool thing is that not every one of these distributed system points has to have all of the rules. So I can do a very small deployment in terms of like a T3 micro or T3 small as opposed to a C5N large instance to be able to do that. Now, one of the other things that we do is we do something called a smart group. This is how you actually define what am I looking for. So in this case, for instance, I'm going to call it the AWS WordPress app. So I'm going to use native tags and native attributes to be able to say the resource type I'm looking at is a virtual machine. It's in the environment of production. It's in the role of web. It's application WordPress, and it's in the AWS cloud. So now using those native tags, I've zoomed in on what I'm looking for, and I can now use that in a rule. Allow this kind of traffic, allow these kind of workloads to talk to these other workloads, but this is defining it in a way so that now the controller says, I know where that application is. So in the example I just gave, those rules might just be pushed here in an AWS environment because it's an AWS WordPress app that's running. But if I had a multi-cloud rule, something that would be traffic between clouds, I might push those to different locations throughout the distributed system. And the controller is intelligent enough to know, based on those tags, where to push these rules. Now, the nice thing is we do more than just distributed firewalling. This same distributed architecture can be used for IDS, for vulnerability scanning, for URL filtering. We go all the way up to layer 7 decode, and we can do what we call microsegmentation. So in this case, what I mean by microsegmentation is you might have an application that has 2 instances inside of a VPC. Well, that traffic, that communication isn't going to go out across our distributed system, so we will actually use the native security groups and automatically configure that communication for that VPC or for that communication inside the VPC. Now I'll give you some idea from a price performance perspective. So this is a real customer of ours, 290 VPCs. They have 30 Palo Alto Networks firewalls in 5 regions. That's costing $15,000 a month just for the underlying compute to support those Palo Alto firewalls. They each get 7 gigabits per second, so an aggregate of 210 gigabits per second. Now looking at it with our distributed system, we have 580 instances there, which freaks out a lot of people, but you're not having to manage 580 instances as part of a distributed system that gets managed by itself. But these are T3 smalls, so the total cost is $10,000. So you're saving a lot of money, 33% lower cost in terms of how much the underlying instance costs. Each one of them can do 5 gigabits per second, which is less than over here, but in aggregate, because I have 580 of them, I can go 2.9 terabits of actual traffic that can handle in bursting mode. So this is a much better 14x the performance in a distributed model. And another big benefit is that this is a very large failure domain. We've had customers that had their firewall cluster go down. It takes down their application entirely, sometimes for 10, 15 hours that it takes to figure out what the problem is. Here it's a very small failure domain, so it's only taking down a VPC or something that's that specific application. Another thing to look for is NATing. We have seen customers that have NAT gateways that are costing them nearly $1 million a year for one NAT gateway, because it's a NAT gateway that's connected to their data lake, and the way that NAT gateways are charged for it is the per hour charge and then a per gigabyte charge. So we have a place where you can go on our website, kind of help you look at where the costs of your NAT gateways might be, and if you find that you're spending a lot on a NAT gateway, you can replace the NAT gateway with an Aviatrix NAT gateway. We don't charge the throughput charge, so you can save a lot of money. I think we're going to save Nike like $5 million a year just replacing some NAT gateways. The nice thing about this, though, is this becomes one of those distributed nodes. So you can now take that distributed firewall capability and use it for egress filtering. So now your NAT gateway is not only NATing, it's actually being able to communicate and filter the traffic for things like PCI compliance. So when you do that, it's a non-disruptive deployment. You don't have to replace your AWS transit gateway or anything. This is just used for for egress, so you don't have to replace it. You can just put it in the VPC. So this makes it so that it's a very nice kind of rolling way to get here. You can start by replacing a NAT gateway and saving money immediately. You can add egress filtering to that so that you improve your security. You can then move to a full distributed firewall capability, and that's when you can really take a bite out of, say, your last generation firewall licensing fee. So it's a nice progression. You don't have to boil the ocean to do it. You can get there over time. You can get used to what we're doing and using the distributed cloud firewall for egress and get used to it. So we're doing demos in the booth. So every time you saw one of these little demos, we're doing these demos. So if you like what you heard and you want to explore it a little deeper than what I had able to do in 20 minutes, come to our booth. I think it's booth number 890. There's a big clue, says Aviatrix up over top of it. We can help you do a cost analysis, look at how you're, where you might be able to save some money, or we can do a full Aviatrix flight school, which basically will get your hands on the keyboard and see exactly how this works. Not only the distributed cloud firewall, but all the visibility and everything that goes around with it. So I have 4 minutes. If anybody has any questions, I'm happy to answer them here. Otherwise, I'll be around after and in the booth. Yes, sir.
Can you drill down into like the router level if we have like the Cisco router between our on-prem and?
Absolutely. This is some of the advanced networking capability we do. We support full BGP. We can do BGP path prepending so that we can have, primary routes and secondary routes. This is one of the big reasons that people will go to Aviatrix is because of the advanced network. I just didn't cover a lot of that in this presentation, but our technical guys could go as deep as you want. Anybody else? Questions, comments, cuss words, anything? All right, well, thank you very much for your time.